So I look to see, where do I have y's and u's together? Isn't that right here? So what's the derivative of that thing? What's the derivative of e to the u? E to the u. Times. Now, where do you have u's and x's together? Isn't that right here? So what's the derivative of that thing? 2x. So coefficients normally come in front, so I don't care if you put 2x, e to the u, or 2 e to the ux. Does order matter when you're multiplying? Doesn't. Now, if you put that for your answer, well, I'm looking at it wrong, what did you forget to do? You forgot to substitute back. So 2xe, what was u really? X squared. There's mine. Everybody okay? Now, sometimes you really got to stop and think, because they'll be, if they get longer, but they don't get harder. Is everybody with me? I'd rather have long and easy than short and hard. So let me show you one that would be a little longer. Y equals 3x plus 1 over x minus 2, and the whole thing is to the 5th power. Now, if that was to the 2nd power, I might multiply it out. But to the 5th power, I'm just not going to do that. So what am I going to let u equal? I mean, I need single letters to powers, correct? So what am I going to let u equal? Yeah, that whole fraction, 3x plus 1 over x minus 2. Then this will become y equals what? U to the 5th. Now, when I use u substitution, I've got to use the chain rule. So I write down my chain rule. The derivative of y with respect to x is the derivative of y with respect to u times the derivative of u with respect to x. Okay. So I've got to find somewhere that I have y's and u's together. So I'm looking, I got 3 statements on the board, but only one of them have y's and u's. That's y's and x's, that's u's and x's. This is the one that's got y's and u's. So what's the derivative of this thing? 5u to the what? 4. Okay. Now I've got to find where I've got u's and x's together. Well, that's using, that's not it, there it is. But now, what rule am I going to have to use to do this derivative? Quotient rule. So it's like starting a whole new problem. All right? Where do you start on quotient rule, top or bottom? Bottom. So I copy down x minus 2. What's the derivative of that numerator? 3. Just 3. Plus or minus on quotient rule? Minus. Then I copy down that top, 3x plus 1. All right, what's the derivative of that bottom? 1. And the whole thing is over the bottom what? Square. Everybody okay? So I've got a 5u to the 4th. Now look, I can't factor anything out, so I'm going to multiply that numerator out. So that's going to be a what? A 3x minus a what? 6. Is everybody with me? All right. Minus, what's that going to be? 3x plus 1. Now, all that is over what? X minus 2 squared. Now, if you want to do it like this, you can if that bothers you. I mean, if you'd rather put 5u to the 4th right there and then do it like that, that's the same thing. Is everybody with me? So I've got 5u to the 4th times, so to speak, So do we understand that I'm gonna have a 3x minus a 6 what? Minus a 3x what? Minus a 1 over x minus 2 squared. So we'll come over here. So I've got a 5u to the 4th. What goes out in that numerator? The 3x's go out, don't they? What's that leave me on the top? Negative what? 7 over x minus 2 what? Squared. Now what's my last step? To substitute back. What was u really? It was 3x plus 1 over x what? Minus 2. But that whole thing's to the what power? The 4th. And then I've got a 7 over an x minus 2 squared. Everybody okay? Now, what does this 4 go with? Does it go with just the top, just the bottom, or both? Goes with what? Both. I mean, if you had 3/4 squared, wouldn't that mean 3/4 times 3/4? So you'd have 2 of the 3's and 2 of the what? 4's. So do you understand that on the top, I've got a 3x plus 1 to the what power? A 4th, and then I got a 7. On the bottom, I've got an x minus 2 to what power here?
2.
What's this one though?
Oh, sorry.
To a 4, is everybody with me? And then I've got another x minus squared, x minus 2 what? Squared. Question, Carrie Beth?
Isn't it a -7 here?
Oh, thank you. It is a -7. Or anything else we need to fix? Now, can I clean that denominator up? What happens when the bases match and you're multiplying? What do you do with those numerators? You add them. So I can do 5 times this -7 and get a -35. And I've got a 3x plus 1 to the 4th. And how many x minus 2's do I have? What do I do with those exponents?
6.
Add them. 6 is right. There's my trick. So you've got to learn this chain rule. Okay, you got to use that chain rule. All right, so let's make sure we're clear, and then I'm about to show you a way to avoid the chain rule. But you're going to have to do some of the homework problems using them. On the test, I'm never going to tell you when to use it and when not to use it. I just need you to be able to use it when you can. So do we understand on this chain rule? All right. First thing you're going to do is you're going to have to let u equal something. And you have to decide. And people will say, well, how do you know what to let u equal? And I keep saying you need to be your own fairy godmother. And look at the structure of problems. Let me show you what I mean by look at the structure. See, when I look at that, here's what I see. I see the cube root of something. So let u be the what? Something. When I see this one, I see something to a power. Is everybody with me? So I let u be my what? Something. When I see this one, I see e to something. When I see this one, I see the cotangent of something. So when you look at the structure, what you let u equal should be pretty clear pretty quickly. Now, then I want you to substitute that into substitute that U into the problem. So you understand what I mean by substituting U into that problem? So suddenly this becomes the cotangent of U, or E to the U, or U to the 10th, or U to the 1/3. Then you're gonna have to do dy to dx is dy to du times du to dx. And then what's your last step gonna be? And then you're gonna clean that up. So I'm gonna put simplify. So that's just algebra cleanup. What's your last step? Substitute back. Is everybody okay? Now, I'm giving you that derivative, excuse me, the derivative formula sheet. It's in your book on that front flap. This is just a different form of it. I think mine's a little more user. I also posted it on Moodle. All right. And so if you lose it, you can just get it off the Moodle. Now, let's talk about what it says. Number one is nothing different. What's the derivative of a constant? 0. Number two just says when you have things separated by pluses and minuses, can you do the derivative separately? Yeah, nothing new. Number three is nothing new. Number three basically says don't touch numbers in front. Okay? Now, 4 is different. Here's what's different about 4. 4 is called an extended power rule. All right, so it says this. What if you have a whole expression raised to a power instead of a letter raised to a power? Now, what you've been doing is a special case of this one. You've been doing this the whole time, you just didn't know you were doing it. Look what the rule on your sheet says. When you take the derivative, what happens to your power? It does what? Comes down, just like it's been doing. I've been saying it, and you've probably not been paying any attention. I wasn't paying any attention. I kept saying your expression stays the same. And then your power, what? Goes down by 1. Now, here's the one new part. You've got to multiply by the derivative of the inside. Now, you've been doing that the whole time, and I'll show you how. So this red part's really the only new thing. Now let me show you why you've really been doing it the whole time. Isn't X what's in your bracket and your parenthesis? Well, look what you were doing. The 5 was coming down, your expression was staying the same, and your power was going down by 1, right? Well, because they were single letters, what was the derivative of the inside all the time? 1. So it wasn't showing up. Now, let me show you how to use this and avoid the chain rule. All right, give me example 1 that we did a minute ago with the chain rule. It was a square root, wasn't it? What was it? Y was the square root of what? Look back in your notes, what was it? 4x plus 5 to the 12. So suppose I to avoid chain rule. Now, I can put dy over dx, that stands for derivative. I can put y prime, now both of those stand for derivative. So it's totally up to you which way you write it. Most people tend to do this unless they have to. So look at the chain rule. What's my f of x up there? Do you see my f of x is 4x plus what? 5. So what does this rule say I do? What do I do with that 12 and what? Comes down. Now, what happens to my expression? It stays what? The same. So it stays 4x plus 5. What happens to my power? It comes down by 1, 11. But I'm not finished. What do I still have to do? I've got to do the derivative of the inside. Is everybody with me? So what's the derivative of that inside? So when I clean that up, I have what's 12 times 4? 48, and I've got 4x plus 5 to the what? Isn't that what we got last time, the chain rule? All right, second example. What was y on that second example?
Square root of 6x squared minus 2.
6x squared minus 2, carry back? Okay, now again, what about still got to change the root to? What do roots get changed to all the time right now? Powers. So y is 6x squared minus 2 to the 1/2. Okay? Isn't that this? Something to a power. So what's the extended power rule say I do? Well, what happens to that power at what? Comes down front. What happens to your expression? It stays what? The what? The same, right? What happens to your power? Don't you subtract 1? What's 1/2 minus 1 going to give me? A negative what? Now, I'm not finished. What's the one extra step that you got to worry about? You got to do the derivative of what? The inside. It's like starting a whole other problem. So what's the derivative of that inside? 12x. Well, I can change the order on multiplication by that commutative property of multiplication, right? So what's half of this 12x? So I've got 6x. Why am I not happy if you leave me this for your test?
Negative x prime.
Negative x prime. So that 6x stays on the top and I move that down to the bottom. Isn't that what I got last time? Everybody okay? All right. Look at the one we just worked. It's number 5, I think. Well, I'll go back and work the other 2 in a second. Didn't we have a whole fraction to a power? What was my numerator? What was my denominator? Was it to the 5th power? Okay. See, that's something to a power. So if I don't want to use the chain rule, what happens to my power? Comes what? Comes to the front. What happens to my expression? Stays what? The same. What happens to your power? Goes down by 1. Is everybody with me so far? Now, what's my one extra step? Remind me. The derivative of the inside, of the interior. Is everybody with me? In your interior, a fraction. So it's like starting over. What are you going to have to do the derivative of a fraction? What's your rule? So you start on the bottom, and then you do the derivative of the top, 3. And then we'd have minus, my top is 3x plus 1. What's the derivative of my bottom going to be? Just a what? A 1. And that would be over my bottom what? Now, I'm not going to finish. That's the same thing we got a minute ago. You just have to clean it up. So do you see how rule number 4 on that derivative formula sheet is gonna save you from using the chain rule if you don't want to use the chain rule? Is everybody okay with that? All right. I need you then to look at number 6. Number 5 is just your quotient rule. We know the quotient rule now, right? Number 6 on the formula sheet is just the product rule. We know we already got over that, those two last time, right? Now, on number 7, I want to look at this special case for a second. We'll talk about the the one above it next time. Now, I don't want you to get number 4 confused with number 7. Here's the difference. This one's power rule, this one's not. You don't take the X and bring it down. Is everybody with me? Power rules when you have letters to numbers. Number 7 is when you have numbers to what? To letters. Now, we're going to do the special case first and get good at it because it occurs the most. The most common number that you're going to see is E. Is everybody with me? But you've been used to E to the X. Number 7 on that special case doesn't have E to the X. It has E to the what? F of X. Now, here's what you do with your derivative. You've been doing it the whole time. What's the derivative of E to the X? The derivative of E to the F of X is E to the F of X. With one additional little part. You have to have the derivative of the power. Now, once again, you've been doing that the whole time. See, y equals e to the x. The derivative is just e to the power times, but what was the derivative of your power all the time? It was just a 1, so it didn't show up. All right, so look at the example that worked. It's either 3 or 4, wasn't it? 4? What was it? E to the x squared? All right, so let's use this rule right here on that one. Y equals e to the x squared, and I want to take the derivative. Now, I don't want to use the chain rule. I want to use this extended e rule. So what's the derivative going to be? The first thing I do is just copy the original, right? So I write down e to the what? X squared. Now, what's my one extra step? I've got to take the derivative of this power. Does everybody see that? All right, I've got to take the derivative of that power. What's the derivative of that power? 2x. Isn't that what we got with the chain rule? But faster. So what if your function was y equals e to the 8x? What would the derivative be without using the chain rule? What would I do? Put down what? E to the 8x first. Now, what's the one extra step you've got to do? The derivative of the power. What's the derivative of 8x? 8. So I'd have 8e to the 8x. Is everybody okay? Now, next week, we're going to go over the log ones on number 7. So next week, we're going to go over the general one above that. If it was 2 to the x, it's 2 to the x squared instead of e to the x squared. All right, now, 9 through 14. These are all the ones you're supposed to have memorized with one extra step. What's at the end of every one of those that you've not seen before? Derivative of the angle. Again, you've been doing it the whole time. See, if you had something like this, y equals, now, what was number 3? we did, it was a sine of what? 5x. All they were doing on the special case was this. And you were told to take the derivative. Well, what's the derivative of sine x? Cosine what? Because here's the derivative. If you have sine of an angle, then your derivative is cosine of that same angle, but you have to say times what? The derivative of the angle. Well, see, every time when you had like, what's the derivative of that angle? Your angle is x, so what was its derivative? It was just a what? A 1. Well, now it's not a 1. So what's the derivative of sine 5x? Well, the first thing is it's what? The cosine of what? 5x. It's the cosine of that same angle. Now I've got one extra step. Go back and circle your angle. And then just do this like starting over. What's the derivative of that box part? The derivative of 5x is just what? 5. Now, it's not 5 times 5x, it's 5 times the cosine of 5x. If you put the cosine of 25x, that's not right. So what if I gave you this one? Y equals the tangent of something strange like 3x plus 1. Is everybody with me? I mean, something, you know. Now, did you memorize the derivative of tangent? I hope so. Or you're behind. What's the derivative of tangent? Secant squared. So the derivative of this tangent is what? Secant squared of the same angle. Is everybody with me? What's the one extra part on all these trigonometries? You got to know the derivative of the angle. Well, there's my angle. What's the derivative of that thing? 3. So I've got 3 secant squared 3x plus 1. Everybody okay? Now, the advantage to not necessarily using the chain rule is sometimes with the chain rule, you got to use the chain rule inside of other chain rules, and that gets real sticky. Because you on this part's not the same thing as you on that part, and you start looking all around your paper. Now, what do I mean by that? Here's what I mean by that. If you do it piece by piece by piece, you will not get confused. So what if I had this? Whoa! Remember I told you to look at the structure of it. Because I see E's and powers. Y'all see E's and powers? You think, well, I got E rules and power rules. How do I know? What's that structure? That is something to the what? 5th power. You need to do power rule first. So help me out here. What happens to my power?
What's the front?
Comes to the front. What happens to my expression? It does what? You're going to be saying this in your sleep by the end. It stays what? The same. What happens to your power? It goes down by 1. Now, what's the one thing you have to do still that you haven't done yet? The derivative of what? The whole what? Inside. That's like starting a whole new problem. Okay, we can do that. All right, another rule. See, I went from rule number 4, now I'm getting thrown down to rule number, what is it? Number 7. What's the derivative of e to a power? E to the what? Power times what? The derivative of the power, okay? That's some different rules. I'm using 3 rules all of a sudden. What's the derivative of a negative x? -1. Doesn't it say minus? Because now that flips me back up to rule number 2. Can't you separate them and do them separately? All right, isn't this e to a power? So what's the derivative of e to a power? E to what? The power times what? The derivative of the power, which is a what? 2. But do you see what I mean? I mean, in one problem, it flipped me all over that sheet. But I've got to have tunnel vision. I've got to be looking at one little thing at a time and not freaking out about everything. You know, the way you eat an elephant's one bite at a time. Otherwise, you choke. You won't choke. Then all I got to do is clean it up. So I've got a 5. I've got an e to the negative x minus e to the 2x, and that's all to the 4th power. Well, what's a negative times that? That's going to be a negative what? E to the negative x minus what? 2e to the what? 2x. Now, I don't want you to make an algebraic mistake right here. You can't go multiplying this one times this one. Because don't you have to do powers before you multiply? And unless you want to write this down 4 times and multiply that whole thing out, you're done. You see what I'm saying? I'm going to have to leave it like that. You say, well, you got a negative x on it. Well, I feel okay if they give me one to start with, what? I can give them one back. I just can't give them one to start with if they don't give me one to start with. So on your homework, it's going to be posted on Moodle. There's going to be 2 parts to it, so it's going to take you a while to do your homework, so kind of plan accordingly. I'm going to give you several problems off of page like 164. Here's what I need you to do. I need you to do some of them using the chain rule. I don't care if you only do 2 or 3, but if you're going to do Cal 2, you've got to understand use substitution. Once you can do it, you can leave it and never do it again. Because on a test, I'm never going to say you must use the chain rule. Is everybody with me? Now, the other thing is this. I recorded a video a few minutes ago. Zoom is taking forever to process this video. If it doesn't process right, then I'll have to re-record it tomorrow morning. All right? But it's on a physics application of derivatives. That video is probably 20 minutes. And there's a worksheet that goes with it. But I want you to do these problems first. Is everybody with me? Then go watch that 20-minute video and try to do those physics application problems. It's going to give you a position function, and you're going to have to find a velocity function and an acceleration function. What the video is basically going to tell you is, if you take the derivative of position, that's your velocity. And if you take the derivative of velocity, that's your acceleration. And it asks you some questions that you have to be able to answer, okay? But do this first and the physics thing second, because it should be posted by tonight, but if it doesn't process, I'm going to have to re-record it. Okay, come see me if you need some help.